Hello students, so welcome back to the lecture 6 of your chapter 4, that is linear equation in two variables. So in all the 5 previous lectures we have discussed about many things on linear equation in two variables. There we discussed how to convert a linear equation in two variables in its general form, how to find the solution for a linear equation, as well as we have also discussed how to find the value of k, okay, if a particular pair of solution is given for a linear equation. Understood? But today we are going to discuss about a new theme, a new topic, okay, that has been introduced in your chapter. What is that theory? Hence, today we are going to discuss about a new topic, and the name of the topic is how to draw a graph for a linear equation in two variables. Okay, so our today's title is how to draw a graph for a linear equation in two variables. It means if you have a linear equation in two variables like this, okay, is equal to 6. It is a linear equation. Why it is a linear equation? Because in this equation the highest degree is 1 and it contains how many variables? Two variables, x and y. So it is a linear equation in two variables. Okay. Now we have to represent this linear equation in two variables on a graph paper. Okay, that means this linear equation has been converted into a graphical form. How we can convert it? Let's talk about this. Since there is a term you can see, graph of a linear equation in two variables. Graph means definitely you need a graph paper. Okay, it means we have to represent this linear equation in two variables on a graph paper. Okay, for example, if it is your graph paper, okay, it is a graph paper. Since you have a graph paper, then you can easily draw a Cartesian coordinate system on that graph paper, as we have already discussed about in chapter 3, coordinate geometry. Okay, if you have a graph paper like this, then you can draw a vertical line on it, that is known as y-axis, and a horizontal line on it, that is known as x-axis. Okay, now this terminal is known as x, this terminal is x dash, okay, this terminal is y and this terminal is y dash. Now whenever these two axes meet each other, intersect each other, then they will form four quadrants: quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Now this system is known as Cartesian coordinate system, isn't it? Now we have to represent this equation in this system. Okay, we have to show this equation in this Cartesian coordinate system. How we can represent this linear equation into a graphical form? Let's see. As we have discussed in chapter 3, coordinate geometry. Okay, there is studied there are two systems. One is Cartesian coordinate system, one is polar coordinate system. Okay, in Cartesian coordinate system we have two axes, x-axis and y-axis, and they both meet each other at a point, and that point is known as origin. Okay, and the coordinate of that origin is 0, 0. Okay, let's draw it here. So it is our y-axis, it is our x-axis. Okay, now when they will meet each other, that point is known as origin and the coordinate of that origin is 0, 0. Now towards the right side we have the positive direction for x-axis, so you can name the point 1, 2, 3, 4. Towards the left you have the negative direction of x-axis, -1, -2, -3 and -4. Towards the upmost direction you have the positive direction for y-axis. Okay, 1, 2, 3, 4, 5, and towards the down we have negative direction for y-axis. Okay, so then see that any point can be represented on this Cartesian coordinate system. Okay, on this Cartesian coordinate system you can represent any point. Okay, suppose you have a question to represent 3, 2 on a Cartesian coordinate system. Can we represent? Yes, you can represent. How? Since 3, 2 is an order pair, and in this order pair we have two number or two digits, the first digit represents what? It represents x coordinate, and second digit represents your y coordinate. Now you can easily represent this point on the number line, and you can also say on which quadrant this point lies. Since both x and y coordinate have positive sign, that means they must lie on the quadrant 1. So let's represent it. So x coordinate means you have to move towards the right up to 3 units. So let's move 3 units. Now in y coordinate you have to move 2 units. That means you have to move towards the top, towards the up. Okay. Now move there. Now you reach at this point, and this point is represented as 3, 2. So it is clear that any point can be easily represented on a Cartesian coordinate system. Okay, but how we can represent a linear equation in 2 variables on a graphical form on a Cartesian coordinate system? Okay, isn't very difficult? Yes, it is also very difficult to represent. But how? Which process should we follow to represent it? Let's see. Okay, there is a question arises. If we can convert this linear equation in 2 variables into some points, okay, some order pairs, some points, then we can easily represent it on the number line. I mean to say that if we can convert this linear equation 2 variable into some points, suppose there is AB, another point suppose CD, another point suppose EF, okay, then we can represent those points on the number line. Okay, so now our target is to convert this linear equation 2 variable into their point format. How we can represent them into point format? How we can convert them into point format? Is there any way? Yes, there is a way. How? As we have discussed that a linear equation in 2 variable has how many solutions? It has infinite solution, and for a particular value of x we must get a particular value of y. There we have an example. Suppose this is your linear equation 2 variable. Okay, if you put x to be 1 here, then what will be the equation? Equation will be 1 plus 2y is equal to 6. 2y is equal to 6 minus 1. Okay, 2y is equal to 5 and y is equal to 5 by 2. So you get a solution here. What is that? 1 and 5 by 2. Now you see this linear equation has been converted into a point format. Now we can convert this linear equation into a point format by calculating its solution. Similarly, this is a one pair of solution. You can calculate another pair of solution also. Let's find out. Suppose someone put x to be 0. What will be the equation now? 0 plus 2y is equal to 6. So 2y is equal to 6 and y is equal to 6 by 2, that is 3. So you get y is equal to 3. So what will be the possible pair of solution? 0, 3. Now you get another pair of solution, another point. In this way you can get infinite number of solutions. Let's find out another 2 solutions for this same equation. Okay. Suppose someone put x to be 6. Then the equation will be 6 plus 2y is equal to 6. 2y is equal to 6 minus 6. 2y is equal to 0 and y is equal to 0 by 2, that is 0. So one more solution we get, that is 6, 0. Similarly, let us find one more solution. Someone put x to be 12. Okay, in this equation. Now equation will be 12 plus 2y is equal to 6. 2y is equal to 6 minus 12 is equal to minus 6 and y is equal to minus 6 by 2, that is minus 3. Hence the possible pair of solutions is 12 minus 3. Now for the same linear equation 2 variable, we got how many solutions? We got 1, 2, 3, 4 solutions. And if we follow this process, we can get infinite number of solutions. Okay. Hence, we convert this linear equation 2 variable in which format? In order pair format, in point format. Okay. Let's write all those points. Okay. Let's write all those points. Here we get the points 0, 3, 1, 5, 2, 6, 0 and 12 minus 3. Can we represent all those points on the Cartesian coordinate system? Yes, we can represent it. All the points can be represented on a Cartesian coordinate system. Let's represent them. And now we will represent all these 4 points in this Cartesian coordinate system. So let's representing the first point. So our first point is 0, 3. So in this point your x coordinate to be 0 and your y coordinate to be 3. Since the x coordinate is 0, it means this point should lie on y-axis. Okay, according to the rule. As we studied, if x coordinate is 0, then that total point will lie on y-axis. But we do not know on which direction it will lie. Since the y coordinate has positive sign, it means this point should lie towards the positive direction of y-axis. So let's represent this point on the y-axis. So on the y-axis you have to move up to 3 units. So up to this unit, now this point represents 0, 3. Right. Next, the second point that we are going to represent is 1, 5 by 2. Now, you can also convert this into 1. 5 by 2 means what? 5 by 2 means 5 is divided by 2, 2 to the 4, 10, 0. So 5 by 2 means in decimal form it will be 2.5. Clear? Now, we have x coordinate 1 and y coordinate 2.5. Since both have the positive signs, that means this point should lie in the quadrant 1. Okay, so let us represent this point. So in x coordinate you have to move 1 unit in the positive direction, and for y coordinate you have to move 2.5 unit in the positive direction. So let's move 2.5. This is 2, this is 3. Now this point is 2.5. Okay. Now this point, remove all these things. Now this point represents 1, 2.5. Clear? Next point is your 6, 0. Here x coordinate is 6 and y coordinate is 0. Since the y coordinate is 0, that means this point should lie on x-axis. And since this x coordinate has positive signs, so this point will lie towards the positive direction of x-axis. So let us represent this point on the x-axis. So in x-axis you have to move up to 6 units to represent the point. Now start moving from the origin. Here you are. This point represents 6 and 0. Understood? Next, we have to represent 12 minus 3 on this coordinate system. So x coordinate is 12 and y coordinate is minus 3. Since x coordinate has positive signs, y coordinate has negative signs, that means this point should lie on quadrant 4. That means in this quadrant. Okay. So let us represent them. Now you have to move 12 units in the positive direction of x-axis. So let's move. And in the y-axis you have to move towards the down because it has a negative sign. Up to how much units? Up to 3 units. So let's move to the down. Okay. Now, these two lines will meet at that point. That point denote 12 minus 3. Okay. We are already acquainted with how to representing a point on a Cartesian coordinate system. Okay. Now you can see all these 4 points has been represented on this coordinate system. Now our next task is to join all these points. Okay, we will join all these points. So let's join. These 2 points will be joined. Now join these 2 points. Okay, using the scale. Okay, you should use the scale in order to join these points. Now, okay, now all those points have been joined using the scale. Now our task has been completed. Hence you find that all these 4 points that we get from the linear equation in 2 variables. Initially we have the linear equation that x plus 2y is equal to 6. We have taken this linear equation in 2 variables. Now we find 4 solutions of this equation. Now all these 4 solutions are in the point format are in the order pair format, and these points should be represented on this Cartesian coordinate system. Then all those points will be joined using the scale. Okay, and hence this linear equation has been converted into its graphical form. It means we represent this linear equation in two variables in a Cartesian coordinate system. This is the task that has to be fulfilled. This has to be done. Now it is completed. Okay. Next, one thing you can see here, when all these 4 points are being joined. Okay. When all these 4 points are being joined together, they seem to be like a straight line or not? Is it a straight line? Yes, it seems to be a straight line. So what we conclude here? We conclude that whenever a linear equation in two variables is converted or is represented in a Cartesian coordinate system, then they will form a straight line. Okay, this is this straight line represents which equation? This equation. So we can write a note for that. We can write whenever a linear equation in two variables, okay, are represented, not are, it is represented on a Cartesian coordinate system, then they will form what? Then they will form straight line. Then it will form a straight line. Okay, now understood? So we got that whenever we convert or we represent a linear equation two variable in its graphical form in a Cartesian coordinate system, and when we join all those points, then all those points will combine together to form a straight line. Clear? So this is the conversion of a linear equation into its graphical form. Okay, one more thing we can conclude here. What is that thing? Let's discuss. Okay, so this is our initial linear equation in two variables. Okay, whenever we represent it in a Cartesian coordinate system, then it will form a straight line. So you can see a straight line can be formed not only by 4 points. A straight line can be formed not only by 4 points. It can be consist of a number of points. A straight line consists of a number of points. Similarly, whenever we represent this x plus 2y is equal to 6 on a Cartesian coordinate system, it will form a straight line. Then this straight line must contain a number of points on it. A number of points, not only these 4 points, a number of points. Here. Okay, there are many points. Infinite number of points should lie in this straight line. Okay, let's find out a point. Suppose I am locating a point here. Okay, I am locating a point here. Then can we find the coordinate of this point? Yes, we can find the coordinate. How? As I have told you, you have to draw perpendicular distance to x-axis and to y-axis. Okay. Now the perpendicular distance to x-axis is your y coordinate and the perpendicular distance to y-axis is your x coordinate. So here perpendicular distance to y-axis is 2 units. So your x coordinate is 2. Similarly, perpendicular distance to the x-axis is 2 units. So your y coordinate will be. Hence, the point that you locate on this straight line will be 2 and 2. Let's write that point. This point should lie on this straight line. Okay. Now, in this point, we have the x coordinate 2 and y coordinate 2. If you put this value in the original equation, does it satisfy the equation? Let's verify. What will verify? We will verify if we put x is equal to 2 and y is equal to 2 in our initial equation. Does it satisfy the equation? Satisfies means we have to verify whether this is also a solution of this equation or not. Let's verify. So, here we have the LHS. x plus 2y. Okay, and we have x is equal to 2 and y is equal to 2. Let's put here plus 2 into y is 2, so 2 plus 2 into 2 is 4, 2 plus 4 is 6. So we get LHS to be 6. Now what will be our RHS? Our RHS is also 6. So what we get? We get that LHS is equal to RHS for 2, 2. Okay, so we get, if we put the value x to be 2 and y to be 2 in the original equation, then LHS is equal to RHS. That means this is the original or real solution of this equation. Understood? So we get that if you put any point, lie on this straight line in the original equation, then all the points should satisfy the equation. Not only 2, 2, but also any point you can take. Okay, haphazardly you can take any point. Then that point must satisfy the equation. Let us verify for one more point so that you can easily understand. Suppose I am looking for a point here. Okay, so this is a point that should lie on this straight line, and what will be its coordinate? Let's find out. Okay, now this is your perpendicular distance to y-axis. That means this is your y-x coordinate, and perpendicular distance to x-axis, then this is your y coordinate. Hence x coordinate is 8. This point is 8, and y coordinate is -1. Understood? Now let's put that coordinates value in the original equation. Okay, so here we have x is 8, y is -1. Now here LHS is equal to x plus 2y. So x is 8 plus 2 into y is -1. So 8 plus 2 into -1 is -2. So 8 minus 2 is equal to 6. And we have the RHS is also 6. Hence we get LHS is equal to RHS. And hence if you put x to be 8 and y to be -1 in the original equation, then this equation satisfies. Okay, it means 8 minus 1 is the original or real solution of the equation x plus 2y is equal to 6. Similarly, if you put any point that should lie in this or on this straight line, they must satisfy the equation. We can also try for one more point. Suppose here is a point. Okay, here is a point. So can you identify the coordinate of this point? Yes, by drawing the perpendicular distance. Now you can see this is your x coordinate. So x coordinate is 4, and this is our y coordinate. Y coordinate is 1. Now let us put these values in the original equation and find whether LHS is equal to RHS or not. So here we have x to be 4 and y to be 1. Now our LHS is x plus 2y. So x is 4 plus 2 into 1. So 4 plus 2, that is 6. We have also RHS 6. Here also we get LHS is equal to RHS. Hence you can write, yes, 4-1 satisfies the equation. It means 4 is the real solution of this linear equations. So we conclude that if we put any point that should lie on this straight line in the original equation, then they must satisfy the equation. So write the second note that every point on this straight line, every point on this straight line, okay, every point on this straight line should satisfy the initial linear equation in two variable. Okay, now you understand all these two notes. The first note is that whenever you convert a linear equation into variable into its graphical form in a Cartesian coordinate system, then it will form a straight line. And the second note is that every point on this straight line, okay, every point on the straight line should satisfy the original linear equation in two variables. That means those points are the real solution of the equation. You could try with any points, and you get the same result also. Suppose someone tries to find a point. Suppose that there is a point lies I think here, okay, here is a point. Now you will verify whether this point satisfies this equation or not. Then find out its coordinate. This is its x coordinate, so x coordinate is 10, and this is the y coordinate. Y coordinate is -2. Okay, so you get x coordinate is 10, y coordinate is -2, and our LHS is x plus 2y. So x is 10 plus 2 into -2. So 10 plus -4. 10 minus 4 is 6, and your RHS also 6. So here also LHS is equal to RHS. So it is now confirmed every point on this line should satisfy the original equation. These are the most important notes. Okay. Now next thing. Suppose there is a point which must not lie on this straight line. Suppose we will take a point which doesn't lie on this straight line. Okay. Suppose there is a point, this point. Okay. I am taking this point. Does this point lie on the straight line? No, it doesn't lie on the straight line. It lies just above the straight line. Okay. Then can you find the coordinate of this point? Yes, we can find the coordinate. Let's find. This is the perpendicular distance to x-axis, and this is the perpendicular distance to y-axis. So this is the x coordinate 5, and this one is the y coordinate 1. Okay. So keep in mind that this point doesn't lie on the straight line. Now we will verify whether if a point doesn't lie on the straight line, does it satisfy the equation or not? Let's verify. So here we have x is equal to 5 and y is equal to 1, and our LHS is x plus 2y. Okay, so x is 5 plus 2 into 1. 5 plus 2 into 1 is 2, that is 7. But what is your RHS? 6. So do all these two sides are equal? No, you can write LHS is not equal to RHS. Since LHS is not equal to RHS, that means the coordinates, whenever we put this in the original equation, they do not satisfy the original equation. Hence, 5-1 is not a real solution of the equation. Okay, so 5-1 is not a real solution of the equation x plus 2y is equal to 6. So what we conclude from this statement? We concluded that if a point does not lie on a straight line, then it will not satisfy the equation. Okay, this is the third note. You could write, if, note 3, if a point does not lie on the straight line, okay, then it will not satisfy the equation. Then it will not satisfy the linear equation. Okay, so these are the three most important notes that we can conclude it from the representation of a linear equation in two variables into its graphical form, and you should keep in mind all those notes. Okay, so these are the basics and new theory that has been introduced. Okay.